Welcome back. This is part 11 of our Linux journey, and today we're stepping onto the network. We'll cover the everyday vocabulary of networking, IP addresses, DNS, ports, and then get hands-on with the commands that let you actually see what your machine is doing on the wire. Think of it as learning to read the conversations your computer is already having. Here's the path we'll walk together. We start with the core vocabulary, addresses, ports, and protocols. Then look at how DNS turns names like example.com into numbers your computer can actually reach. From there, we'll get our hands on the modern tools. IP for seeing your interfaces, S for inspecting open connections, and the trio of curl, wget, and dig for poking at the network directly. We'll finish with a calm, step-by-step approach for those moments when someone tells you the internet is broken. So let's start with the vocabulary, because nearly everything in networking comes back to these same three ideas. An IP is the address. It tells the network which machine you're trying to reach, the way a street address points to a building. A port is the door on that machine, a number that says which specific service you want, like HTTP on 80 or SSH on 22. And the protocol is the language they'll speak, usually TCP when you need every byte to arrive in order, or UDP when speed matters more than perfection. Now let's zoom in on that address idea. IPv4 is what you'll see most of the time. 4 numbers separated by dots, like 192.68.1.10, giving us about 4.3 billion possible addresses. We're running out, which is why IPv6 exists with its much longer hex-style format and a practically infinite pool. There are also a few ranges worth memorizing. 127.0.0.1 always means your own machine, and anything starting with 192.168.10 or 172.16 through 31 is a private network. Addresses you'll see on your home router or inside a company. But nobody wants to memorize 93.184.216.34 just to visit a website. And that's where DNS comes in. When you type example.com, your machine asks a resolver, often something like 8.8.8.8, to translate that name into the actual IP your browser needs. You can watch this happen yourself with dig or host right from the terminal. And if you ever want to see or change how your system resolves names, the answers live in etc resolve.conf, etc hosts for local overrides, and on modern systems, systemed resolved. Now to actually see your machine's place on the network, you'll reach for IP, the modern replacement for the old ifconfig command. Running IPA shows every interface and its addresses. You'll spot low the loop back at 127.0.0.0.1 and something like ETHS or 0 with your real LAN address. From there, IP-link focuses on the interfaces themselves. IPR shows the routing table, how packets find their way out, and IPBRA gives you a clean one-line per interface summary when you just want a quick glance. Once you know your address, the next question is, what doors are open? That's where SS comes in, short for socket statistics, the modern replacement for netstat. The combo to memorize is sudo ss, tlnp, TCP sockets, listening only, numeric ports, and the process behind each one. Read it like a list of who's home. SHD waiting on 22, Postgres bound to localhost on 5432, Nginx serving 80 to the world. One command, and you instantly see what your machine is offering to the network. Now that you can see what's listening, let's flip it around and actually talk to the web ourselves. 2 tools dominate here, curl and wget. And the easiest way to remember the difference is this. Curl inspects and talks. Get downloads. Reach for curl when you're poking at an API, checking headers with I or sending a post. It prints the response straight to your terminal. Reach for wget when you just want a file on disk, especially a big one, since it handles resuming with CC and even mirroring whole sites with R. But before you can talk to a server, you have to find it. And that's where dig comes in. A plain dig example.com gives you the IP address behind the name, and that alone answers the most common outage question. Is this a DNS problem or something else? Add a record type like MX for mail, TXT for verification records, or AAA for IPv6, and you can inspect any piece of a domain's configuration. And by putting utter 8.8.8.8 in front of the name, you ask a specific resolver. Handy when you suspect your local DNS is lying to you. Once you know the address, the next question is simple. Can you actually reach it? Ping is the knock on the door. It sends small packets and times how long they take to come back, so you see both reachability and latency. Traceroute goes further, mapping every router between you and the destination, so when something is slow or broken, you can point to the exact hop where it falls apart. And Mr. rolls both together into a live, continuously refreshing view. Packet loss and latency per hop, updating as you watch. So when someone tells you the internet is broken, don't guess. Walk this ladder, and the problem reveals itself at whichever rung first fails. Start with IP*A. Do you even have an address? If yes, find your gateway with IPR and ping it. That tells you the local network is alive. Then ping 8.8.8.8 to confirm you can reach the wider world by IP. And finally, dig a known domain. If that's the only thing that fails, your DNS is the culprit. 4 commands, 4 layers, every time. Let's put that ladder to work on 3 problems you'll absolutely run into. Connection refused almost always means the service isn't listening. STLNP pipe through grep tells you in one line whether anything's actually bound to that port. Can't find this site, while the rest of the internet works? That's DNS. Dig the domain, ping an IP, and if only the dig fails, your resolver needs attention. And when things just feel sluggish, Mr. traces every hop and shows you exactly where packets are being lost or delayed. Before we wrap up, 3 traps worth knowing about. First, if config is deprecated, it might quietly hide interfaces or addresses, so reach for IPA instead. Second, don't judge the whole internet by a single ping to 8.8.8.8. Some networks block ICMP entirely, so back it up with curl, eye against a real website. And third, on modern distros, editing, etc. resolve.conf by hand is usually pointless. Systemed resolved or network manager will overwrite you. Go through the proper manager instead. So here's a small cheat sheet worth committing to memory. When something feels off, walk down the stack. IP*A to confirm you have an address. IPR to see where your packets are headed. TLNP to check what's actually listening locally. Then dig to test name resolution. Curl, I to poke the service itself, and ping to ask the simplest question of all. Is anything home? 6 commands, and you can diagnose most networking problems you'll meet. Let's pull it all together. Networking is really just that trio repeating everywhere. An address, a port, a protocol. And DNS is the layer that lets us use names instead of numbers. Reach for IP and SS as your modern eyes on the system. Curl when you want to read a service. Get when you want a file. And when something breaks, work outward from your own machine. The problem is almost always at the first step that fails. And that brings us to the natural next step. In Part 12, we'll move from looking at the network to actually working across it, using SSH to log into remote machines, setting up keys so you're not typing passwords, building shortcuts in your SSH config, and moving files around with SCP and rsync. You're 11 lessons in and well past the basics now. I'll see you in the next one.